Hi, welcome back. Today I am going to be talking about this auto transformer, also known as a Variac. This is what this one looks like, the front and the sides. Watch how we can dial up and change the output voltage straight from the wall, and then we'll open it up to show you how it was put together. And finally, how accurate is it? Let's test it with a multimeter. Basically, when we are testing our equipment or devices under test, sometimes we don't want the full 240 volts to come out from the power point. And this allows us to change that AC voltage to the test device just by turning this dial. On here, the input is, from our mains is 240 volts, but this allows us to go from 0 all the way up to 300. So it does have a step-up function as well. So what I'll just do is do a quick show of how it looks like, and I may pull it apart and we'll have a look inside. There's been many Variac reviews on YouTube, and I'm just doing this one to show this model in case somebody wants to buy one as well. This is the top. This is the front. These are the sides, just like this, and the bottom. Okay, you see we have a plug coming out here. This is a 1000 VA model, the input voltage and the output voltage. We have a power switch and an LED display here. What I will do is just give a quick demo of how this is used. I'm going to put this here. I'm going to plug this on. So this is just my wires exposed test line. These are the mains. Let me see if I can put this somewhere that's out of the way a little bit and you can see it. Okay, let me move this over here and we'll move this like this. Okay, all right, so I'm going to switch this on. This is at 0 volts. This is an AC bulb. So let's switch this on. Okay, I'll turn this. This is the indicator here. As I turn this up, you see the bulb light up a bit more. You can see the bulb get brighter and brighter. We're at 100 volts based on the display here. This is pointing, can't quite see from the top, it's here. So it's up there, but not quite. And yeah, and basically as I keep turning, you see the light get brighter and brighter. Okay, 160 volts, 180 volts, 195, 200, and 240. Okay, this is how bright it is. So yeah, and we can turn this down. Now this could be a motor, it could be any sort of device that I want to be testing, and we want to be able to bring the voltages up slowly to make sure there's no short circuits or any big dramas that might cause a bit of a explosion. So this is a part of the equipment that allows us to do that. This in conjunction with a isolation transformer, which you may have seen in one of my other videos. So you put an isolation transformer, this plugs into that, then we have a Variac, and then we can test the device safely without any short circuits to ground. Yeah, so it's pretty cool. All right, not much to it, quite simple. So there are different models of different power ratings. As I said, I chose the 1000 VA. Let's open it up and see what it's like inside. I'm going to take the front panel off first. And what do we got? On the front panel, we've got our little digital display here. There doesn't seem to be any little trimmer pots that I can see that would have been useful to maybe tweak it if we needed to, but there's none there. This is a overprotection button. Oh, okay, so this, if something goes out, there's a button here to reset it, I suppose. I didn't even realize that. Quite cool. This is the fuse, and this is the power switch. This is the plug. Now I just wanted to check, because what I've seen on other videos is that this ground that came from the power socket, right, the power line, which is here, this ground wasn't connected to the chassis, right? So we got this ground here, it's connected to the switch, the power point, sorry, and that goes here, which, if I can try to bring this up, you can see is hard fastened to this screw here. Now the thing is, I'll open this up, if there's a layer of paint here that this is tied to, not a great connection. Let's remember these devices, you know, made in China, they really made affordable compared to how much they used to cost. So I really appreciate that. But, you know, they're made as cost effective as they can be. So there will be some small little shortcuts, right? Shortcuts like soldering direct to these connections on the sockets, which, you know, are good connections and everything, but for maintainability, you know, having those little sockets that you can slip on would be ideal onto the connectors. A lot more easier to maintain, like I said. Okay, so this seems to be good. I don't see a ground connection on this outer part here. Okay, well, this is just hot glued here onto the case as well. This is also just hot glued here. Not loving that. So this socket is actually hot glued. I don't know if you can see the hot glue, but it's hot glued here. Let me see if I can zoom in. Can you see the hot glue? There's the hot glue here. There's some hot glue around here and here. Yeah? So not fantastic. Yeah, not fantastic at all. Like I said, costs will be cut where possible. So that's one thing to note. If I know if this ever gets loose over time, I know why. They have the screws that go into the chassis here. So these big long screws go into the chassis here, which would provide grounding, right? But you will see here, there's a nice layer of paint. That paint is not gonna, it's gonna provide some insulation, right? So there probably won't be a great connection between this and that. Means we might want to take some paint off here and here. Don't love the idea, might cause some corrosion, but that's one way. Another way might be to put a wire from here, the ground that's there, and connect it to the chassis here somehow. Maybe put some, grind away some metal here and solder the wire there, or put another nut or something like that. Okay, so here's the basic wiring, bit of mess of wires, just enough to put this together. It's a power switch that connects here, switches on the display. Yeah, okay, not much to it. Next part is to disassemble the rest of this parts inside. Yeah, okay. First I'll have to try to take off this thing here, I think. Yep. Okay, let's do the next part. I'm a bit wary, I don't want to break the wires. I don't know if you can see here, but if you can see this black wire is just soldered to the coil wire. So I'm a little bit worried about it being, you know, broken basically. So I need to be very careful here about how I handle these things. Oh no, wait a minute, there's 2 holes. Interesting. Oh, that's great. There's no... Okay, this does not have a flanged end, a flat side, to make sure you put it on the same way. So I just need to make sure, as I had it before. Okay, so let me remove this screw. Gently, gently take off the cover. All right, so how do I show you this? This here, I believe, this is the wiper. You can see it's a nice big wiper here. Okay, let me try to center this. So this is the big wiper. You can see here. Again, I'm being very careful about this wire. The brush here wipes along the top surface of the coils. And you can see here, there's even some rubbish on here. The coils at the top have been sort of cleaned. The cover on the wires have been cleaned, the coating, so that the wiper can actually touch that. Let me just give all this a bit of a brush. Okay. So yeah, so this wiper here, the yellow wire down here, interestingly, it wraps around. Okay, I'll try to show this sideways. Inside here, you see the wire, which sort of just wraps around the post. Not sure if I'm loving that, but I get it. Okay, maybe another reliability concern there. It is loose though, so hopefully it doesn't break. This is the earth connection that was basically tied here. So the screw would touch this and go through into the casing inside. So I suppose that's okay, there's no coating, but that would provide the grounding connection for safety. And this is the mains power here, right, which is on another coil connection there. You can see it there. Okay, so it's just a bit awkward to hold this. Okay, so yeah, I just think this wire connection here has the screw, but this screw is not actually touching, right? It's not actually touching because this is on the outside of the case on here, which is coated, right? Okay, I just want to show you what I decided to do. If you can see that, I just scratched the paint off here so that this connection, when inside, will touch on here and provide the contact. So I'll do that as well. On the other side of insulating this, I think I will, at a later point, drill a hole from the bottom and scratch the paint off inside and tap the wire that I will solder to this ground connection here, and then wire that down in the corner. I think that'll be a more practical way of doing it, but I will do that later. Alright, so basically that's all that's inside. So yeah, this thing just goes around, touches the wiper. As it works, because you have the mains voltage here, right? And so as it goes all the way to the right, more and more of the coil is being used, and more of the voltage that's coupled through gets passed through to the output. As you turn this anti-clockwise, less and less of the coil is being used or touched through the wiper, and so that process of passing through the voltages through the wires is less. And I'll try to show a drawing of that maybe. The instructions do say to clean the coils every so often. I think this wiper material, since it's new, yeah, a bit of stuff is coming off. You see there? I'm just doing this here. You can see, I don't know if you can see it. Try to zoom in again. Yeah, you can see this this gunk that's come off the brush. Something to keep in mind again. So this is a good thing about opening up stuff and seeing how they're put together and see what things need to be done to make them a little bit better. Okay, so I'm going to make these mods as I mentioned and put it back together. Some brief testing, you know, this display versus where this pointer points doesn't necessarily match what the actual voltage is. And this is sort of a issue with Variacs. It's very hard to get the exact outputs here and there. I've seen many people do a review and that's the same problem they seem to have. They've changed the dials, they've changed these things here. And again, it depends on the input voltage coming in from your line, whether that matches exactly as well, what you might match here. So to give you an idea of how the dial setting versus the meter setting versus the multimeter reading to see what sort of voltages we get from this. So I'm going to switch this on. And you can see we've set it 0 volts at the moment and it's 0 here. So as I turn this up, okay, we're at about 30 volts now. I've got 38 on my meter and I've got 33 on the Variac meter. Let's turn this up. Okay, we're at 60, about 70 volts on the dial, 82 on the meter, and 79 on the front display of the Variac. So it's a little bit out. Let's get up to 100. So it's about 100 there, I think, on the dial. We have 115 on the meter, 117 on the multimeter. Let's take it further up to say 150 on the dial, 169 on the front, and 168 on the multimeter. So you can see it's a bit out. Yeah. Let's continue this up to 200 volts, 220, 229, 30, 230 on the front meter, and 226 on the multimeter. So it's getting closer as we get higher. So if we get to 240, which is probably where I would be testing. Let's see. If I take this 240 on the dial, the front says 279 and the meter saying 270. So let's take it back to 240 on the meter and it's 236 on the multimeter. So you can see there's some plus and minus in terms of accuracy of what's on the dial, what's on the multimeter, and also what's on the front reading. And this also depends on the voltage at your line supply, right? And even if you change the markings on your dial, if the input voltage to the Variac varies a bit, it will adjust what it actually is reading again. So if you're really concerned about accuracy, the best thing is actually to put up your meter, your multimeter on the output to double check it, to make sure it is at what you expect it to be. So thank you very much for watching. I hope you got something from this. I hope you see that the Variac has a role to play in terms of being able to change the voltages as we need them for testing, right? And that you seen something for yourself that's useful. So please do like and subscribe. Let me know if you have any comments or any feedback. And hopefully this video has provided some value for you and you enjoyed it too. Okay, thank you so much. Look forward to catch you in the next video. Cheers. Bye.